Hi class, I'm here to talk to you a little bit about creating a geologic history. We're going to use the 7 principles, or a few of the 7 principles that we applied in chapter 12 to evaluate geologic time, and then I'll talk to you a little bit about types of unconformable contacts as well. I'm going to walk you through exercise 16, which is the example here that's part of your lab, or sorry, exercise on page 100 that's got 16 events, I should say. And I'll just show you how we kind of identify different features here and then how we fill in the table down below. And you'll have a couple to do on your own. I'm just going to switch over to my pen tool down here on the bottom. And that way I can sort of do some highlighting and some writing in. You'll notice that each of the layers here in different colors. Q, for instance, is a different sedimentary layer, sedimentary layer, sedimentary layer. W, A, all the way up to R, where we have a surface up here which has a tree on it. So that's the most recent erosional surface. So I typically work from the bottom to the top, and we need to be able to identify a few of the symbols in here as well. So we're going to start at the bottom, and the first symbol we come up in contact with here is this little blob. That little blob is an inclusion, so it's a fragment of Q that's been put into W. That formed through the process of erosion, so it was eroded at the surface, and that's why this surface is irregular. And so we know that Q must be older than W based on the principle of inclusions, and that's one of the 7 principles, right, that we've applied in chapter 12. We see inclusions here as well in E, and what's interesting is that we also see a weird symbol here that we may have seen before. That symbol is just to indicate that the rock here, A, N, N, and then A and W and Q here have been heated. So it's contact metamorphism. And so that means that this dike that intruded up like this came out to the surface, heated the rocks around it, and heated the rocks below it. We're going to interpret it, though, as a flow that came out to the Earth's surface rather than a sill, which would have intruded between the layers. If it was a sill, we would see symbols like this up here along the top, and we don't see that, so that those symbols again indicate heating of P. That means P wasn't present to be heated, and so E was up at the surface on its own. All right, so we can go through this process from bottom to top. The first thing that had to happen down here, we're going to start in position 1, is that Q has to be deposited. We then have an erosion period. I'm just going to write ER for that, okay, which creates these inclusions, followed by W, no erosion there, followed by A. Let's fill in these few that I lost track. We have Q, we have erosion, we have W, followed by A, followed by N. Now we have to have warping of these layers, so we'll have folding. Seven will be erosion again, because we have inclusions in E. So we have erosion here. Now we have 8, we're up to 8. And we have intrusion of E, so E comes in and intrudes as a magma. At 9, we have a process that you might not have known to include. I wouldn't necessarily say it comes right after E. It could be associated with E, which would be metamorphism, right? Contact metamorphism. So metamorphism, just to abbreviate here. Okay. Followed by then again erosion again, because we see inclusions up here of E in P. So we know that we have erosion. Let's see, 11, we're going to be followed by the deposition of unit P, which is up here at the top. 12, now we got to Z, which is here. No erosion between those two units, so deposition of C or Z. Okay. Now, you'll notice this contact here is not horizontal any longer, so we've had some sort of tilting. Something like folding, some sort of deformation. We notice here at the top we have Z in R as inclusion, so we have erosion, followed by the deposition of R, And then finally, this surface is irregular and eroded, so we have erosion at that surface. So that would be the next, essentially be a disconformity, right? So here we have a disconformity, angular unconformity here. Okay? We have another disconformity. Okay? Strictly speaking, I guess you could call it a nonconformity, but usually we have igneous rocks or metamorphic rocks of Paleozoic age, so really it might be considered a disconformity. And then finally here we have another, angular unconformity on top. And that works out the geologic history. The only thing we haven't really covered in here is faulting, and so you will see that in some of these examples you have a crack that runs up through these rock layers. The principle of cross-cutting relationships is what you want to use to go ahead and interpret that. So processes that you'll want to include: deposition, erosion, deformation or folding, intrusion is a process, metamorphism or contact metamorphism you should be able to include as a process, and then tilting or folding we've already talked about. Okay, so that wraps it up for creating a geologic history in Lab 9.